Good morning, everyone. Thanks for joining today our session, and thank you, ma'am, to accept our invitation. And that Dr. Kanika is currently now chair of IEEE-NTC Women in Nanotechnology and the senior manager in American Bureau of Shipping. And the title of the today talk is the Nanotechnology Education and Research for Social Impact. Before moving the today plenary talk, I want to brief introduction of the session speaker. Dr. Singh is a senior member of IEEE and working as senior project manager at American Bureau of Shipping. Dr. Singh pursued her education from top universities like Indian Institute of Technology, Delhi, Karlsruhe University, Germany, and PhD from Busan National University, South Korea. With her 25 years of IEEE membership, she took various roles and positions at IEEE. Now serving as the advisory board member of IEEE-NTC Tri-Nano and IEEE WISE. Also serve as a vice chair of IEEE IMS EMBS Delhi chapter. She is recipient of various technical fellowship awards and academic awards. Few of them include the prestigious Brain Korea Fellowship Award, Best Paper Award at IEEE-IS CATS, IEEE Outstanding Young Engineering Award, that German Government Fellowship Award. She currently as a chair of IEEE-NTC Women Committee. Her main motive is in developing and implementing systematic for sustainable strategy for WIN committee plans in 2022. Thank you, ma'am, for accepting our invitation. Now, floor is yours, ma'am.
Thank you, Pawan, for giving a nice introduction. And it is my pleasure, and I'm really pleased to be a part of this workshop symposium for the students. Starting, I'm going to share my slides. Let me know if you can see my screen.
Yes, ma'am.
Okay. So for my presentation today, it's a very detailed perspective which we have been taking up on education and research and some of the impacts of social network on nanotechnology. So my presentation today will be covering several topics. In fact, a brief introduction on nanotechnology and education and product and market development and also the social impact. And then I'll discuss on IEEE-NTC Women in Nanotechnology, which is our new committee started in 2020, and we've moved ahead in 2022 by growing the network more progressively. So this will be introduced today. So I think Pawan has already covered most of my accomplishments and brief introduction. I've been a senior member for IEEE for 20 years as a membership and senior member as 5 years. So I'm covering almost 25 years of IEEE membership now. And there have been several achievements during my lifetime where I pursued my education from IIT Delhi and also had been away, I've been working in various countries, including I pursued my master's in Germany and have been working in. It started my journey of nanotechnology started actually with my microelectromechanical systems, that is MEMS, and where I was introduced in KU Leuven in Belgium. There's a institute IMEC where I was first time introduced about our microelectronics and microsystems. And so on and so forth. The journey had been in various interdisciplinary fields, covering nanotechnology side on the sideline. So yeah, so I think nevertheless, already my achievements and my awards have been already introduced. So I know we all are here talking about nanotechnology, and but I just wanted to touch base some brief and generic information, which may be a background for my presentation today. So this is history and cross-disciplinary. So we actually perceived that the first ever concept was introduced in 1959 by a famous professor, Richard Feynman, and the invention of the scanning tunneling microscope in 1981, and the discovery of C60 in 1985, which led to the emergence of nanotechnology. And the term nanotechnology was coined by Norio Taniguchi, that was a Japanese guy in 1974, and they recognize there's a lot of plenty of room within the micro nanotechnology. And the timeline has been from various years. I didn't cover the main, but of course there have been passive nanostructures, which are dispersed, and contact nanostructures, products, and aerosols, colloids, and proteins, and nanoparticles, and polymers and ceramics, active nanostructures like bioactive health, targeting drugs and biodevices, physiochemical actives, and then we have the third generation, that was systems of nanosystems, that was guiding assemblies or networking a new hierarchical architecture, and robotics and evolutionary. And then was the fourth molecular nanostructures, which were designed for the emergence from the atomic to the nano. Okay, so when we talk about nanotechnology, what quickly comes to your mind? You don't, when you go into traditional engineering aspects where we talk about electrical, mechanical, of course, computers and other engineering backgrounds. But nanotechnology as such, of course, has come up like an emerging area. We still have cultural interdisciplinary behavior in this nanotechnology, where we have a diverse experts which can emerge into this field. And like, of course, sensors, electronic, nanoelectronics is part of it, and there is medicine, health, information technology, energy, material science, food, agriculture instruments, drug delivery, and I think tunneling into optics and fuel cells. So various emerging fields are recognizing the importance of nanotechnology. So when we do the nano analysis, it's like the nanochemistry, biotechnology, nano-optics, and nanoelectronics, which innovatively we can develop this nanotechnology field. So moving ahead, now I'm here today with actually, I have done some various research on POCDs, and also the MEMS and micro nano field. But recently, we are working with some of the universities here for developing the curriculum accordingly. It was not only just to focus on the curriculum of universities, but also we also try to introduce nano aspect in high schools. So this is some pilot project in plan and in discussion, which is ongoing with some of the Korean university in collaboration with some US counterparts. So I'll just briefly mention how we are working on this direction. On the other hand, I must say that, scientific foundation of nanotechnology is to understand the phenomena of nano. So before actually we get into developing this education, of course, we have institutes providing nano education, but at a primary level or an engineering level, we still lacking behind on some of the aspects. And what are the roadblocks during this nano education is first and the foremost is visualization. We wanted to introduce nanotechnology to our like high school, where we recognize the fundings to provide the visual aid to see the nano aspect was missing. So the first roadblock we recognized from the high schools was the we have several microscopes and magnifier, surface polyphotometric or AFM or SEMTM. So these kind of equipments are not easily possible for any high school to introduce. Then on the other hand, when we talk about the core universities, which of course I think private universities have already come up with many various innovative fields, but our core traditional universities are focusing on the traditional engineering degrees, having the basic engineering like electrical, computer science, or mechanical or chemical. So that was another roadblock. And then how to develop the skills in this, because it's not only just you read it as curriculum and you understand, and you need a proper clean room and proper systems available to you to give some experimental understanding and research. So all this aspect, and then not only that, if we have those kind of extreme engineering manpower available, we do need an industrial application and industrial jobs for them, or maybe academical jobs for those kind of manpower we are heading towards. So there has been some very detailed discussions on this aspect with the university areas and some of the industrial partners. So we still have, some, of course, taking the class and then building up the gap between the research and the clean room technology. So there is a lot of literature available on that aspect, and we have also trying to anchor and from various understandings from various universities, and discussions are ongoing, and we recognize some structures of education. That is, one is T structure, then we had the pi type education structure. So in the T structure, they just mention the basic courses and introduce some interdisciplinary curriculum for them. But they're not like very nanotechnology oriented. Then we had another pi type structure where we had a discussion or some meetings with Michigan State University and Stanford Silicon and MIT Caltech, where there is some scope of adding some practical engineering and also some research-oriented programs, but mostly it's on the graduate level or postgraduate levels. So those pure sciences has to be a part of this whole curriculum, because that starts from where initial stages. On the other hand, the third we recognized, there was some papers we found was on undergraduate research programs, that is divided into level 1, 2, 3. And as you see, the level 1 has some current research topic, ethical research, and data collections, and so on and so forth. And then second was introduction of nanoscales and characterization and fabrication, imaging methods and manipulation techniques, and fabrication. And then introduction of molecular mechanics, and also then nanotechnology modules were developed on freshmen. This mainly from the Virginia Tech University. And of course, we cannot learning some technology, methodology, but application is most also important. So we need to have a social technical integration, considering the human aspect also, where human is maybe the user, or is this device may be used for some diagnostics or treatments. So we have to adhere to every aspect in education. Right. So we're still working on this curriculum, and then we have a double education track system for freshmen or sophomores or seniors, and where we have some basic fundamentals of engineering, which every engineer goes through. We have some double major electives where they can select any elective related to them. Also, we have that's sometimes some free choice of their electives, and then providing some graduate preparatory courses and core elective and economic. And then we have, of course, maths and computer skills will be also part of the curriculum, and considering some innovation venture to be added with some trainings and some internships or dissertations within the curriculum. So that's another aspect. And then we do need to touch base on information technology and cognitive sciences and biotechnology. So there's some pilot plan in South Korea we're just trying to set up was on extreme engineers, where we are trying to collaborate with some engineering societies and universities to make some manpower pilot program. And on the other hand, we do try to extract what are the famous or nanotechnology universities and nanoscience centers. And in the world, we recognize it's like China has 86 and US has 86, Germany is 28, South Korea is 28. These are the top 5, and UK has 17 on the top universities list. So still we have a lot of scope where we do have possibilities of providing a proper, the education system. And in this course of time, we still are working with some of the top professors here, and having some Teams meeting on and on with some of the state's professors, and some expert panel we have side from India and China, Japan, and trying to make up some curriculum improvements on where we have, starting with solid state electronics, solid state with photonics and ionics, and the extreme. And then we talk about materials and millimeter wave material and electrochemistry. And because when we identify nanotechnology as such a cross-cultural education, and also it's more of a very interdisciplinary field where we need a lot of skills and knowledge in order to proactively work in this field. So, of course, engineering on microscopic machines, MEMS, actuators, intelligent materials, superconducting devices, and we touch base on chemistry and the physics and mathematics and computers and thermodynamics. And still, this is under discussion and development on what all to be, fed to our expert engineers who will be the final manpower for nanotechnology as such. So this is a very brief plan. It's called the Extreme Engineer Education, called it E3, and it's an EQ project where this a joint curriculum steering committee was developed in order to supervise this nanotechnology course. And then we already contacted several colleges and education on this aspect, and nano lab excellencies are required in order to provide the education at at the base level of nanotechnology, and suitable curriculum for the new growth of the engineers was developed. And then industry feedbacks were also created on surveys provided by them and the custom needs. So anyway, any product which is nano product, if you say so, is like connected directly to the user, and we do have to have a user interface to understand the need of the hour today. So of course, as a researcher, as a student today, you have only a bubble where you are focused on your research. But when you do a market survey, it's a different scenario as such. And we want to encourage that kind of, that gap should be filled, because education should be useful in their skill development and their further job-oriented work should be available to the students. So just to let you know, I don't know if you've ever had a chance, like IEEE-NTC has a Tri-Nano forum, and it's a very, you can search trinano.org, where we have many universities around the globe that currently offer nanotechnology degrees. And the list is growing back and forth. We're working on this forum, and we've compiled and developed a comprehensive global list of universities offering certificate, undergraduate programs, graduate, and PhD programs in nanotechnology. If you're seeking any course in nanotechnology opposed to a specific degree, you can, or you can actually go into individual course of the nanotechnology, and it can be within mechanical engineering department or in the electronics department, but we've already listed out all the most of the, you can actually search through countries. So we recommend you to reach out to each universities if you're considering, and confirm their availability on those degrees or whatever. So this forum, Tri-Nano forum, we are trying to improve. We will have another aspect which we are trying to add in, is to mentoring. And also we have a plan to introduce the industries which are maybe interested on nanotechnology students, and their maybe you can find your internships or your programs there. So we're still working on it, but yes, the listed universities are well defined there. You can find any country nanotechnology institute, most of them are listed on there. And then other, I think I can also refer you some National Nanotechnology Coordinated Infrastructure. Nano Hub is also very interesting, where you can get a lot of information for the students on this. So yeah, now this was about the education pilot program. Maybe I cannot give you all details here, but yes, I could give you a brief understanding what we are planning and our curriculum development, which is ongoing to have not only at the postgraduate level, but to bring nanotechnology as a degree or as a, self-sufficient discipline. And this is ongoing. Then on the other hand, we did a survey on how the nanotechnology research versus the market. So you have many, it's a lot of products, and we talk about, we develop, we print research publications, but how many of those researches or the patents are now in the market or are getting there? Yes, there is a lot of scope, and this is emerging, and a lot of companies are using nano, but still we still are struggling on some aspects, and some gaps are still there on the. So first, I think the application that food sciences, nanotechnology, health, delivery, nanodiagnostics, and physical sciences, nanofilters, tissue engineering, and also beauty. Nowadays, nanocosmetics are also getting very popular, and engineering constructions. And of course, we started with carbon nanotubes and the surface protection materials, painting, nanopaints, and solar panels, food products, thermal patches, and bandages, which are also another common part of it. And yeah, you might have studied a lot of various applications from the, maybe the automobile engineers or even the health system. It's very useful for the health system, and then diagnostics like PCR test, or maybe there are so many other ways. Then we have the, the telecom or any other. So yes, we know there are many applications where we fit very well in the system. Now, first is expectation. Now, expectation on nanotechnology have not been met sometimes. If you see the overall view, because there are some technical to economical barriers, because cost versus function, cost versus the product is too high. In setting up the nanotechnology, the whole system, as well as the total production, it is quite a costly affair. And then on the other hand, to attempt to drive from material to the application, sometimes not, it's not the best solution, which we recognize. And then tailored material is required for technical needs like nanomaterials and uneconomic or niche market, and we need scalability on that. And then potential technology solution achieved with non-nanomaterials. So these are some of the consequences. And what happens is companies at times skip the nanotechnology, R&D of the nanotechnology, and due to the cost aspect, or maybe some other like investment to fundings are not available, they are saturated, and new products and innovative are stagnant, and market focus sometimes come down. So these are other aspects. So where is this? There's like technology, nanotechnology, and then the engineering or the researcher are trying to push the product into the market. And on the other hand, the market engineers are still struggling to get the product in the market. And there's still need of additional skilled personnel, and I think those material and macroscopic to new product, environmental technology, I mean, those environments should be easily available for the product to be sustainable in the market. So there are many other issues which are still struggling here. So when we had some of the meeting or discussions with the nano industries, it's like they do have issues with commercialization of those products, and that is therapeutic efficacy, scalability, sometimes clinical trials. Even the physicians, they don't support clinical trials for any nano detection or nano treatment, nano drug delivery, and inadequate regulations. That is one of the major factors, because standards is very much required in this field. And then safety and reproducibility, and poor intellectual property rights, and quality control. So these are some of the challenges which the companies face. But though we still have many companies, internationally renowned companies who are working on this field. And on the other hand, if you see in India, is another boom where we have various companies which are working in this direction for nanoscience and nanotechnology. And you can see those companies are well distributed over the India map. So there are a scope. This is not a presentation to discourage you in this field, but yes, the young generation, young engineers have to fill in those gaps, or with the support of their faculty, and how we can focus on developing a skill-based manpower for nanotechnology. So in social impact is I just wanted to cover a different aspect. Yes, we have several social impact of nanotechnology, which I think I already talked about the health and maybe drug and treatment, and it is useful in many other ways in various automobile industries. But here we are trying to tackle some the sustainability goals. So I hope you must be aware that sustainability goals from 1 to 17 have been put up with UN, and many of the companies are focusing to get the sustainable environment, and so on and so forth. SDG 6, as you see here, is one of the sustainable environment that includes nanotechnology research. So to improve wastewater and also better management of it. And so these are some of the perspective of nanotechnology towards sustainable environment, to have a sustainable wastewater treatment process, and solid waste treatment and transformation, then nuclear analysis of soft and hard nano interface, nano membranes, filtration, and models of nanophase separation, nanobio interactions, and rational design of nanomaterials, nanosensors for humidity, nutrients, water quality, and nanopollutants and synthesis. So this is some of the impact which we are focusing on. Now, this was some of the part of what research or what we are focusing on the work. But coming back to as IEEE-NTC, first of all, I think I should congratulate your chapter. IIT Indore has won the best chapter award from NTC this year, and I think this is one of the very good opportunity and congratulatory event for the chapter. But for future, I think I've seen the chapter has been working very proactively and actively with various activities and events being introduced. And for many members here, I want to try to motivate and give them some insight, IEEE. Like, I think when I foresee IEEE, it's like the tree of opportunities. Your education, your research, your everything is on one side. But when you join IEEE as a professional society, it's your professional development. And it focuses on your future. And where you get some local, global networking and recognition, and also enhancement, because you improve your knowledge, meeting various mentors and coaches, or maybe some pioneers in the whole scenario. And you enrich your knowledge base and also develop career building resources. So it's IEEE is nothing without members. And so we need to have engagement in this. And I must say that IEEE recognizes and they provide equal opportunities and equity and justice to all the members in this forum. So I think it's a good start if some people are interested in going into IEEE. I also joined IEEE at a very young age, and so on. That's why I'm completing like 25 years of my membership. And then I want to introduce IEEE Women Engineer. It's one of the forum. It's a very huge IEEE forum where Women in Engineering offers several discounts on registrations and fundings and opportunities. So I think this will be another aspect where you could be recognized well as a woman engineer in WIE, what we call it. And it also is completing 25th anniversary this year. And this WE has taken up promoting like men and women together. It's not only for women, and trying to affiliate. So we as Women in Nanotechnology is one of the affiliate group of Women in Women in Engineering. And they do support you with the STEM for volunteering positions or funding and awards. So I think that's another aspect where you can grow yourself. And I'm sure if you are today attending, you must be knowing about our NTC council. That is it's a multidisciplinary group where with purpose in advance and coordinating work with nanotechnology and mainly scientific, literary and education areas. And we have various societies who are members of IEEE Council and NTC Council, and this is the aerospace, antennas, circuits, communication, component packaging, and computers and EDS. So nanotechnologies has many chapters and they are growing. And then I want to introduce now is our Women in Nanotechnology. I'm chairing this committee. So first and foremost, Women in Nanotechnology, actually, what is our main objective when we are talking about WIN? We call it WIN, and it is elevating NTC Women WIN committee members and value them, enhance the knowledge base by developing programs and activities, by supporting TC activity, Try Nano, and recognize women achievers and outstanding achievement awards in IEEE field. We are organizing sessions, workshops, forums, and at annual NTC conferences, and enhance the networking to promote women and promote member rate enhancement of women from fellow to senior member, and flagship events like involving some regional coordinators. And NTC would also join the efforts for strengthening the diversity. So we are already pledging with for strengthening the diversity, and we consider men and women as equal. So this is how we are heading towards. So we have added the prospect of diversity, inclusion, and equity within the WIN. And as you know that even UNDP and UN are always focusing on diversity. And they say we, as a sustainability development, we leave no one behind. And if this is just in embracing everyone's uniqueness, And it's not only diversity is only about men, women, but it's also about the culture and the race and maybe some special requirement, and then even gender-based. And so many diversities are available. Like India itself is the biggest diverse country with different possible diversities available there. So I think that's another thing. So IEEE mission is to foster technological innovation and excellence to benefit humanity. Requires the talent, perspective of people and different personnel, cultural, disciplinary backgrounds, and committed to diversity in technical professional, promoting inclusive and equitable culture for gender, religion, disabilities, and national origin, sexual orientation, or gender expression or identity. And that's why we have a committee called TAB. We call it Committee in Diversity and Inclusion. And WIN is actually associated with TAB, which is one of the responsible DEI aspects. And then we encourage our team to support in this direction. And I want to just cover like for our DEI aspect, we are trying to encourage more and more members, and that will help you to provide member upgrades and recognition and some support like travel grants or awards. And presently we see female members are still very low as compared to the male members, and we need to bring up these numbers on higher level so that we can come to some equality on this. And I know the female members have various issues due to which they are not able to join, or maybe they have to take a break in their career. But I think IEEE always gives an opportunity for women to grow. And for IEEE WIN committee, Fabrizio Lombardi is the NTC president, and he is our resident. So normally our approvals and everything is coming from our NTC president. We have the secretary at Perkins, and then we have our WIN advisory committee, James Morit. He was the NTC past president, James Spicer, Trinano chair, and we have Vincent Puri, who is our he's IEEE region director, and also we have Maka Shiva, the one of the professor who is NTC prominent member. Then Professor Duncan, she is deputy chair of IEEE Technical Committee in Education. And then we have also recruited two regional coordinators, Pawan Kumar for Region 10, and Stephen Okiniwi, he's from Region 8. And I think these are newly appointed regional coordinators. And I really would like to, I think, mention that Mr. Pawan Kumar is doing a very proactive support to our WIN committee. And we've also increased our WIN committee members and actively promoting and supporting WIN events in this. So as a WIN, we are focusing on multi-generation membership, and we want to break the bias that women and men cannot have like we just want to have that breaking of the bias, and we give a opportunity for any gender and provide equal identity and expressions, and chair and encompass so underrepresented countries, and providing funding to the different race and for traveling. Also, we are going to work on this aspect. And recently, one of our we also proposed the award for WIN, so it's under the approval committee. So as you see NTC membership statistics, you can see Region 10 is on a very high number, and that's a very good sign of Region 10. And also we see the young professional members are pretty high, and women members still are on a lower as compared to the overall members, but not very low. So I think NTC also have their annual conferences in various places. So I think you have a chance to work on with them. Then these are some of our visibilities. Like WIN committee has also the LinkedIn. We keep updating our LinkedIn, and we have members from Canada, Germany, India, Denmark, US, and various followers. So I would recommend you to join us on the LinkedIn. We keep post about our activities going on. And for in WIN activities recently for 2022 has been, we invited Professor Pramana Boris. She is one of the vice president in Georgia Tech University, and she is the editor and of the book called Women in Nanotechnology, which was well recognized. And then we invited Professor Celia Shenas. She is the chair of Women in Engineering Committee for 2023. So she is one of our. Then we had another event that was a virtual roundtable event with Professor Lombardi, the NTC president, and Delmark Novak. She is the TAB DEI chair, and Jennifer, who is Women Engineer chair this year. And we had a lot of discussions on how we can improve on WIN activities, providing the diversity, equity, prospects and challenges. So that's another. And I've been invited to some of the NTC local chapters that was in, I think, from Coimbatore University. They have a chapter for Women Forum, and they invited to introduce about the women in nanotechnology. Then we had another IIT Roorkee invited me for a lecture for diversity for sustainable future. They have another NTC chapter with the electronics communication engineering. And yes, I think it's a big congratulations to both our regional coordinators to support in our WIN committee objectives. So I think a lot of recruitment is going on in this aspect. Then this is our upcoming event for the NTC WIN DEI Leadership Series, where we have invited, I think, many nanotechnology leaders to introduce about their stories, their life journey, and their research. So I think it will be very interesting lecture series, and you can join us and by either scanning, or probably you can go into the website of NTC where we have provided a registration link, and it's free. So feel free to join us and to improve and to learn something new from our leaders. So finally, there's another future plan which I'm working on, is on developing a DEI ad hoc committee. And I'm also proposing the DEI award. And for this, presently some survey and questionnaire is being developed to develop some ad hoc committee and governance governance. So and some training program on DEI aspects. So that's one thing we want to do. And I must say that as a WIN chair, we are trying to build and sustain an integrity culture, and our goal is to create inclusive, equity, welcoming new members with a variety of background, voices, and roles and contribution. And that's why we also are trying to help underprivileged students of India. I'm been contacted by Angel Express NGO by raising the bar to eradicate poverty and give some free education or supporting the underprivileged children of street of Mumbai. So that was one of the goals we are working on. So not taking much time now and trying to say, please join us. And if you are feeling to learn something or maybe join us to organize or have an idea, feel free to contact me through email. And you can also join us by registering online. If you register online, then you will be evaluated and we'll bring you to our mailing list. And I think thank you for giving me this opportunity for um, introducing WIN here. So that's all for me today.
Thank you, ma'am. Such a nice session on nanotechnology education and research for social impact. And now, in audience, if you have any query, please unmute yourself and ask any question to our speaker.
Thank you, ma'am, for your mesmerizing information regarding nanotechnology education and, of course, about women in nanotechnology. I just want to ask you, as a nano researcher, what should we initiate at this level to reduce the gap between industry demands and the research we carry out?
Yeah, so I don't know what is actually your like presently process in IIT Indore, but as I remember in IIT Delhi, we had sometimes we had some projects running from different industries, and where we get an opportunity to communicate with some of the industries, and we also our professor tried to bring our like as a student could join some international conferences with the industrial aspect. So I think either your faculty actually first should be proactively making some filling this gap, because I think they have many contacts, and they can easily make some first step, and then some forums should be advised in between. Like we should not only have conferences just having academic conference, but keeping some industrial people involved, and they feel where you get a platform to discuss with them. And yeah, those are the some of the areas where you can talk about and bring this gap, fill this gap. So I think it should be some some plan of how to make this gap filled.
Thank you, ma'am. We will try.
Yeah.
Any question from audience?
Hello, ma'am. I appreciate the non-technical efforts. Being from academic background, we don't think about this stuff in general. But now that you have shed some light into this matter, I have two questions. First is there are prominent fields like astrophysics and even in engineering, civil engineering, mechanical engineering. So people from young age they aspire to be an astrophysics or a mechanical engineer or something like that. So can we take nanotechnology to that level that young people will aspire to be a nanotechnologist one day?
I think very good question. This is when we started our discussion and making this pilot program for education and the manpower for nanotechnology. The first thing we did was a survey with the young generation, including the high school, what you aspire to be, but none mentioned. Even if we take about some, we put some questions, and that included and that also included some aspect. And then it was about the thing we mentioned was there was nobody answering that nanotechnology is one of the field. So I think we still are struggling, and that's why we need either these nanotechnology should be coming up as a degree, as a proper degree, not on but then we were struggling with developing the curriculum. You can see how big the curriculum becomes because it's a totally interdisciplinary program in where we learn chemistry and physics and bio and whatnot. So I think there is a chance to get to that level, but the initiation has to be started at some level, some programs and some development of this kind of, pilot plan has to be come up. Yeah, so that India also shines as one of the top 5, I think, nanotechnology institute, because I see China is 86 institutes already offering nanotechnology. And still, I think India need to catch up on this aspect.
Thank you so much, ma'am. That answers both of my questions. So, yeah.
If no one any question, so once again, thank you to our speaker. Thank you, ma'am, joined to us, and we are grateful for the time and effort you took to share your thought and experience with our IEEE-NTC community and IEEE-NTC women in nanotechnology.
Thank you, and thank you very much for inviting me, and thank you, Pankaj, for actually proactively supporting our WIN community. And I hope your fellow peer groups can also bring some efforts on this direction. And recently, I must say, I haven't been to Indore, but I saw Indore is a very beautiful city. One
Yes,
of the Netflix program is covering about Indore a lot. The whole the program, I forgot the name, but they mention Indore city, and I hope someday we will have a face-to-face meetings soon.
yes, ma'am. Yes, ma'am. Sure, ma'am. Thank you so much, ma'am.
Thank you. Okay. Yeah.
Thank you, ma'am.
Bye.
Thanks a lot for accepting our
Thank you.
invitation.
Thank you,
That was a
man.
very wonderful talk. Thank you. Thanks a lot.
Yeah. Thank you.